So good morning, good afternoon, and good evening, guys, based on the time zones you all are coming from. So guys, before we start with the session, can you all please give me a quick confirmation if you all can see my screen and hear me loud and clear as well? Perfect. Thank you for the confirmation, everyone. So before we get started, let me quickly introduce myself to you all first. So my name is Neeraj Kedia, and I've been working in this IT industry for more than 13 years now. So before we get started, let me quickly introduce our Edureka Masterclass with you all. So this Masterclass community, we started back in 2019, and since then we have been closing in to almost 30,000 members so far. And in these webinars, we conduct in this community, we conduct more than 100 webinars and live events on different topics, including blockchain, IoT, artificial intelligence, big data, on RPA, PMP, and multiple front-end and back-end development technologies. And the best part about these webinars are they are absolutely free of cost, so there are no charges involved here. And these webinars are a really great platform for anyone who is looking to get into the industry by learning the technology that is required for you to work in that specific domain. And to be a part of this community, we can simply click on join this group, and then we will be able to get the access to all the webinars and live events. Along with that, we'll be also getting the access to the recordings as well for the webinars that we are going to attend. All right, so today we are going to start with an agenda on why mathematics in machine learning, what exactly we mean by linear algebra. Then we are going to discuss on multivariate calculus. Then we are going to talk about probability, and then we are going to talk about statistics as well. All right, so let's get started. So if we talk about the mathematics for machine learning, then all the aspiring machine learning engineers, they often tend to ask, what is the use of mathematics for machine learning when we have computers to do it all? So, well, that is true. Our computers have become capable enough to do the maths in split seconds, where we would take minutes or hours to perform the calculations. But in reality, it's not the ability to solve the math, rather, it is the eye of how the math needs to be applied. So we need to analyze the data and information so that we can create a model that learns from the data. So mathematics can help us in so many ways that it becomes mind-boggling that someone could hate the subject, right? So of course, doing math by hand is something we hate too. But again, knowing how to use mathematics is enough to explain the importance of mathematics as well, right? So again, we know that in terms of the mathematics and machine learning, then there is we can say a good amount of weightage in terms of linear algebra. Then we also have a good understanding on statistics and probability. Then it comes down to multivariate calculus and algorithms, and then rest of the 10 parts are for different components, which includes the iron vectors, and we have the other statistical, or we can say probability as well. So first of all, we are going to talk about linear algebra. So linear algebra is used most widely when it comes down to machine learning. It covers so many aspects, making it unavoidable if you want to learn mathematics for machine learning. So using linear algebra helps us, we can simply optimize the data operations that can be performed on pixels, such as shearing, rotation, and much more. We can understand why linear algebra is such an important aspect when it comes to mathematics for machine learning. So we can start off with mathematics for machine learning now and understand as much as we can. Now remember that no one can master anything in a go. It takes time, patience, and real-world experiences to help us master math. But this article for sure will help us out with the basics that we are going to discuss as a part of the presentation step by step. So first of all, in linear algebra, we are going to talk about scalars. So scalars means value. So in simple terms, scalars are just values that represent something. It can be something like the size of a house to temperature in an engine. Scalars can help us represent them and their values. So the mathematics in scalars is just simply arithmetic value here. So scalars is equal to value. So we can see a small example to help us understand better on how this is a part of machine learning itself. So suppose a laptop costs around 50,000 and it is on sale for 50%. That means it is half the price and we calculate the price by dividing it by 2, correct? And if you want to buy the same laptop or we can say same laptop, then we have to put again. So for example, if you're looking to buy 5 of these laptops, then we have to multiply the sum by 5, correct? And that too, which is on sale, which is 25,000, correct? And again, if you're looking to buy some accessories as well, then that is going to cost us 5,000 more. So the total cost is going to be 55,000. And since we are getting it at 50% discount, which is highly unlikely, then we are going to get it for 25,000. Correct? Now, next we have vectors. So vectors can get a bit complicated. So to understand that, vectors can get a bit complicated as they are different for different backgrounds. So computer science people can interpret vectors as a list of numbers that represent something. Physicists consider vectors to be a scalar with a direction and it is independent of the plane. Mathematicians take vectors to be combination of both and try to generalize it for everyone. And all of these standpoints are absolutely correct, and that's what makes it so confusing for anyone learning about linear algebra for mathematics for machine learning. So in machine learning, we usually consider vectors in the standpoint of a computer scientist when data is tabular, consisting of rows and columns. So when a data is in the form of pixels, or we can say as a picture, we can consider them as a vector that are bound to the origin and transform them to matrices and perform operations that we shall discuss later on. Now we do have something. Now we can perform multiple operations on vector as well. For example, if we talk about vector addition, or we can refer them as a dot product. So the operation of addition of two vectors, but it is not going to be simply arithmetic. It is actually the displacement that we achieve from working of both of these vectors here. As you can see here, we have vector 1 and vector 2. Now we can see that two vectors, vector 1 and which are referred by v1 and v2 here. So and if we simply add to them, then they affect together. So for example, if v1 has values, for example, v1 has a value as 1 2, and then if we define the value for v2 as well as 1 minus 1, then for the x and y axis respectively, the effective v1 plus v2 will have 2:1 value here, right? So v1 plus v2 is going to have 2 plus again 2 1, which is going to add the scalar values of the vector, and this is also called as the dot product. And then we also have the scalar multiplication. So if a vector is multiplied with a constant, it either grows or shrinks accordingly. So this can be used in something called as a shearing, which basically helps in manipulation of pixel information. So the equation for scalar multiplication is simply the constant multiplied by a or minus constant multiplied by the a as a variable here. So we can see again, this is going to simply help us in understanding the entire scalar multiplication at a much better level. And then we have linear algebra in terms of matrices. So if we talk about matrix and what exactly matrix is, so we can say we can refer to two simple equations for understanding matrix. So for that, we can come down to a notepad. So let's say we have a simple equation such as we have 2x plus 2y is equals to 10. So this is going to be our first equation. If you all remember, that's how we did in mathematics. So here, and suppose here we have second expression or second equation as 4x plus y is equals to suppose 18. And this is our second equation. That's how we did in school as well. So if we multiply equation 1 with equation 2, so since we have these two equations, then by simplification, we can get the result as what? Here we can get 4x plus 4y is equals to 20, and then minus 4x minus y is equals to minus 18. And then this is going to simply lead us to what? Lead us to 3y is equals to 2. And then this is going to simply result in y is equal to how much? Y will be 2 by 3 itself, right? Whereas x is going to be what? X is going to be 13 by 3. That's what it's going to be. So the equation does not, now again, does not have to be this difficult, but think if there was a simpler way to do all of this. And this is where matrices, they come into picture. So if you are referring to this entire equation, then what we can do? We can simply create a small matrix. For example, we can simply project the same equation in matrix as well. For example, here we can define 2, 4, and then we can define 2 and 1 as a simple metric, correct? So this was our first equation, 2x plus 2y. So we have 2 and 2, and then we have 4x plus 1y, correct? So now it is going to be 4 and 1. And this is what? This is the value for x and y, correct? And then this was represented as the first equation as 2x plus 2y was given the value as 10, correct? And then 4x plus y was given the value as 18. So this is going to be a simple representation of the same equation for, or you can say in the terms of matrices as well. Now then it becomes very easy to solve the problem. So we can use matrix operation to solve the problem efficiently. So, but why are matrices so important? That's because they are something which can use to represent in our computers. So functions represent data in a generalized form, and that is the reason they are so essential to understand. So these functions can then be solved to obtain coordinates where we can then use them for something else depending upon the application. So just for the knowledge, we can know that there are multiple type of matrices. So we have row matrix, column matrix, square matrix, diagonal matrix. We have identity, sparse, and dense matrix as well as a part of different matrices here. Now here we can have multiple operations done. So matrix addition is simple process of adding the corresponding elements of two different matrices. It is as simple as that. So C is going to be equals to A plus B, where A and B are going to be two matrices. And that's how simple matrix addition is. And we can move over to matrix multiplication. So matrix multiplication is to multiply the rows and columns, or we can say, let's do one thing, let's refer to subtraction first. So here we can subtract the corresponding elements in this operation. Like we have 2, 2, 4, 1, 2, 3, 1, 4. And if you subtract this again, 2 minus 2 is going to be 0, 2 minus 3 is going to be minus 1, 4 minus 1 is going to be 3, and 1 minus 4 is going to be minus 3 as well, right? And then in terms of matrix multiplication, so we are going to multiply the rows of matrix 1 with the columns of matrix 2. The rows of matrix 1 need to be equal to column of matrix 2 for it to work. That means if there are 2 rows, 2 columns, for example, if there are 2 rows, 2 columns, then then the other matrix also needs to have the same 2 rows and 2 columns for them to be multiplied together. All right. So the rows of matrix 1 need to be equal to column of matrix 2. For example, let's say here we have how many rows? 2 rows, right? That means there needs to be at least two different, now the rows and columns, they always have to correspond together, right? That means the rows of one matrix has to be equal to columns of the matrix 2. For example, currently here we are 2 rows, right? That means there should be at least 2 columns in the other matrix for the multiplication to happen. That's how it works. For example, if we say we have 2 by 2, 4, 1 and 2, 3, 1, 4, then here we are going to multiply 2 multiplied by 2 plus 2 multiplied by 1 as well. Then again, If you refer to 2, 2 multiplied by 3 plus 2 multiplied by 4. 4 multiplied by 2 plus 4 multiplied by 1. Then again, it's going to be 4 multiplied by 3 plus 4 multiplied by, okay, we can say 1 multiplied by 3 and again 1 multiplied by 4 as well. So this is going to give us the end result as a part of multiplication that we can achieve in terms of matrices. Then we have transpose. So the transpose of a matrix is interchanged rows and columns that result in a new matrix. Transpose can be used to flip the dimensions of a matrix or pixel which represent information. So the transpose of a matrix is denoted by a subscript T. And again, it can be seen in this example as well. So like we have A and then we have the transpose being defined by a simple letter T so that we can know, okay, that this is going to be the actual value here. All right, next we have determinant of a matrix. So the determinant of a matrix is the value of a matrix. Specifically, it tells us the scalar of a matrix. So the determinant gives us the product of the values in the matrix. So we can find out the determinant by using this operation here. Like we have A multiplied by EF and E and HI. For example, when we are referring to A, right? So we won't be taking in any other elements of the same row or the same columns. So A, here is what? A is multiplied by EF and HI. There is now this is not this in the same row or same column or as this letter, correct? Same way for B. So if we are referring to B here, so same way if we are referring to B, right? So again, we are not going to make use of the same rows or same column of B. So here we are going to multiply, use D and F and G and I. As you can see here, this is going to be multiplied by B and then same with C here. So what we are going to do with C, again, no elements of the same row or same column is going to be taken up. So again, C is going to be multiplied by what? Multiplied by DE and GH, as you can see here. So it simply gives us the product of the eigenvalues of the matrix. And that is what we mean by determinant of a matrix here. And then we have inverse of a matrix. So inverse of a matrix is such that when a matrix is multiplied by with it, it gives us back an identity matrix. So when is that useful? So it is when we are solving equations and applying transformations to our matrices. And that is going to be the use case for using inverse of a matrix here. So for our 2 by 2 here we have A, B, C, D. So again, if we are going to inverse this, then it is going to be 1 divided by AD minus BC. And that is going to give us D minus B minus C and A here. And then for order 3 and above, here, for example, here we have A, B, C, D, F, G, H, I. And then if we inverse this, then it is going to be the same determinant of A as we had discussed. Next, we have multivariate calculus. So if we talk about multivariate calculus, then the principal component analysis, or we can refer it as PCA for dimensionality reduction, helps increasing the quality of data set. So basically, it is one of the most important parts of mathematics for machine learning. It helps us in solving the second most important problem that we face in developing machine learning models. The first problem obviously being the pre-processing of data. The next is going to be the optimization of the model. So this helps us in optimizing and increase the performance of a model and give us some of the most reliable results. So how does something that almost half of the class hated help us to solve such a problem? So let's break all the ice surrounding this. So it's a simple calculus that we honestly, I personally, I did love calculus. So we have two main components in calculus. We have differentiation and then we have integration, right? So if we talk about differentiation first, then differentiation is simply breaking down the function into several parts so that we can understand every element and analyze it in depth. And they are helpful in finding the sensitivity of function to varying inputs. So a good function gives us a good output, which can be described using a rather easy equation. The same cannot be said for a bad function. So let's say here we can refer to some graphs that exactly define, okay, how good or bad functions, and their corresponding equations are. So if we take a closer look here, it is really easy to break the function of y is equal to ex, where ex is simply going to be the exponent here, whereas it is much more difficult to break y is equal to 1 by x because the function behaves differently for different inputs. So we can say that ex, or we can say exponent, is much more efficient when it comes to varying inputs, but the same cannot be said for 1 by x, right? Now, we may wonder then what exactly is the use of all this, right? So we know which data is sensitive and which is not. Now, to know what exactly we are doing, we need to learn all the basics of differentiation to understand what exactly we are trying to do here. So we can refer to here we can derive the differentiation formula. So let's assume we have a car moving in a single direction only, and it is already in motion. So if we plot a graph of its speed versus time, then it communicates to us how the speed varies as the time keeps increasing and halts after a certain point. Now, if we want to know the rate at which the speed varies with respect to time, it turns out that we are actually finding the acceleration. So the acceleration of the car then would be plotted again as something like this one. And what exactly this means is that acceleration is actually a derivative of speed, because the speed we have here is just magnitude and does not hold more factors for simplification. So if there was no speed, then there would be no acceleration as well. And now we have acceleration, we can justify whether the car had a varying or constant change in the speed while it was moving, and much more than what we wanted to found here, right? And that is all we need in this case, correct? So we can think of, or can say we may want to find the change in acceleration between a certain range in the time span. So we can mark two points as x as and some variable which is going to be a small portion more than x. So we can denote this as x plus delta x, what we have plotted here on the graph. And now we know that this range has many values in between them. So, but what if we want to know the rate of change only between one point and the next, not to the entire graph here, only from these different points? So we know that it is really kind of impossible, because between a range there are countless numbers as a function is continuous. So thus we simply approximate that the limit or the step between two input variable is 0. Now remembering that this 0 is that what we are assuming here, so we can refer this as 0. So it is only the smallest possible value that can make up and not the absolute 0. So if we ever work with absolute 0, we would never have had any function to begin with, right? So this is going to be no, the 0 is basically having some value as 0.00 as well, and some numbers ahead, but never really 0. So that is what, and that's the only way we can put this as. So now we have understood what exactly they are trying to find here. So we can make a general equation out of this. So we can define the equation as, again, the function for x here is going to be the limit for delta x, where delta x is not equals to 0. And we are going to find it by simply adding the delta x minus the x here and then dividing it by the delta x as well. So this is how the formula comes into existence, and this helps us to find the rate of change between one point and the other. And it is such an important concept as it plays a huge role in the optimization of machine learning models here. So now we are going to talk about probability as well. So probability in the simplest of explanation is the chance of something happening, but in a quantified manner. So meaning that there is a number that is attached to something happening. Whereas when we say let's flip a coin, that means there is an equal chance of it being either a head or a tail. So if we put this into numbers, then there is a 50% chance that it could be either a head or a tail as well. And in this formal sense, we can say that probability is a measure of how likely an event will occur. So we can say probability is going to be the event desired divided by the total outcomes. Suppose we have a deck of cards out of which we need to find out the probability that the card we pull out is a heart. So we know that there are 52 cards in a deck, 13 cards of hearts, clubs, and spades and diamonds each. This means that there are 13 cards which we favor and 52 cards that is the total of the cards available. So the probability here is going to be what? It is going to be simply 13 divided by 52 is going to be 1 by 4, and that is going to be 0.25. Same way when we talk about the dice example. So we know that there can be 6 outcomes, correct? Let's say we want 2. So the probability of having 2 out of 6 is going to be simply 1 by 6 itself, because that's one outcome out of 6. So the probability of getting 2 is going to be 1 out of 6 as well. That is going to be called as probability. So there are multiple terminologies available in probability. So before diving deep into the concepts of probability, it is important that we understand the basic terminologies used here. So first of all, we have random experiment. So it is basically an experiment or a process for which the outcome cannot be predicted with certainty. And then we will be having the sample space. So the entire possible set of outcomes for a random experiment is a sample space of the experiment. And then we are having events. So one or more outcomes of an experiment is called an event. It is going to be the subset of a sample space. And then we have disjoint events. So disjoint events do not have any common outcomes. So for example, let's say a single card drawn from a deck cannot be a king and a queen. And then we have joint events. So non-disjoint events can have common outcomes. For example, a student can get 100 marks in statistics and 100 marks in probability. And then we are having distributions in probability. So probability distributions help us understand the kind of data that we are going to work with. So as you discussed, yeah, these are also the type of events, and then we have multiple distributions. So they are going to stand us, they are going to simply give us an understanding of the kind of data that we are working with, how they are distributed, and how they are different from each other. So every aspect of data can be understood, visualized using distributions. Now for machine learning, we are having currently 3 distributions available that we are going to focus on. First of all, we have PDF, that refers to probability density function. Then we have normal distribution, and then we have central limit theorem. So here the first one, as in probability density function, or we refer it as PDF. So it is concerned with the relative likelihood for a continuous random variable to take on a given value. So the PDF gives the probability, or gives the probability of a variable that lies between the range A and B. And then we are having normal distribution, which is going to be a probability distribution that denotes the symmetric property of the mean. It infers that the data around the mean represents the entire data set. And then we are having central limit theorem, which states that the sampling distribution of the mean of any independent random variable will be normal or nearly normal if the sample size is large enough. And then they are we can say they are joint probability as well that we discussed. So which is basically a measure of 2 events happening at the same time. And then we are having conditional probability, which is going to be the measure that an event will occur only if some other event has already occurred. It is dependent on the previous event. And then joint probability is simply the measure of 2 events happening at the same time. For example, the probability that a card is an ace of hearts, or you can say is going to be now here we are going to find the probability of ace of hearts, and there are 13 heart cards in the deck of 52, but and out of them one in the ace of hearts here. And then we have conditional probability, which is going to be the measure that an event will occur only if some other event has already occurred. It is dependent on the previous event. For example, if A and B are dependent events, then the expression for conditional probability is given by the probability of B and A is going to be the probability of A and B divided by probability of A. And if A and B are independent events, then the expression for the conditional probability is going to be given by the probability of B itself. So basically, now we know that the Bayes theorem is used to calculate the conditional probability. It is the probability that an event based on prior knowledge of the conditions might be related to the event. So the formula for Bayes theorem goes again something like we have, it is going to be referred as likelihood ratio. So this is going to be considered as a likelihood ratio, which measures the probability for the given event of A and the occurrence of B. And then it is going to be defined as here the probability of A by B is going to be referred as a posterior, which means that the probability of occurrence of A is going to be given by B itself. And then if you talk about its use cases, then a simple example for this theorem is, let's say, again, suppose we run a clinic where we test if a patient has liver problems or not, right? So now probability that they drink even though they have a liver problem may be around 5%. Prior probability that have around 10% of a patients from before they have had problems. And probably that suppose patients drink, let's say they are 15%. And hence the probability that they do not have a liver problem is calculated now by probability of B by A. It is going to be the patient which may have a liver problem from 5%, and then we have to divide it by the probability that the patient drinks, and that is going to be our probability in terms of finding out the patients which are going to have the liver problem, around 3.33%. And then if we talk about the applications of probability, then it helps us in optimizing our model. It helps us in classification by our algorithms, which requires probability. And then the loss also can be calculated using probability. And the models are built on being probable. And then we have statistics. So statistics is an area of applied mathematics concerned with data collection, analysis, interpretation, and presentation. And it helps us in testing the effectiveness of a hypothesis on the given data set. And that makes it such an important factor in machine learning. So we can understand statistics by looking at some of the basic terminologies as well. So first of all, we have population and sample. So population is going to be a collection of, or you can say a set of individuals or objects or events whose properties are yet to be analyzed. And then we are having sample, which is going to be a subset of the population referred as sample. So a well-chosen sample will contain most of the information about a particular population parameter. So we can see here, so we have a whole population of fish, which is the whole data set. And then we are going to choose a set that represents the population best. And this can be considered as a small example here. And then we have different sampling techniques. So sampling is a process of selecting our samples from the whole population of data, but the sample should be efficient enough so that it is able to help us to tell everything there is about the data. So how do we do that? So we can understand this by simply distributing it again in terms of probability and non-probability. So again, we can have random, systematic, and stratified in probability distribution, whereas in non-probability, we can have snowball, quota, judgment, and convenience, something that we are going to talk about as we proceed further. So in terms of the random sampling here, so we can say the random sampling is basically when each member of the population has equal chance of being selected in the sample. Then we have semantic sampling, which is basically a systematic sampling for every nth record is chosen from the population to be a part of the sample. And then we have stratified sampling, which is going to be a stratum, or which is going to be a subset of the population that shares at least one common characteristic. And in this case, it can be gender as well. So random sampling is used to select a sufficient number of subjects from each stratum. That is why it is therefore as stratified sampling. Now, there are two types of statistics. We have descriptive and then we have inferential statistics. So descriptive statistics is when we are trying to describe the kind of data we are working with. So in general, it describes what the data has and what it covers and much more. And then if we talk about inferential statistics, so this is when we are trying to infer some knowledge. So inferential is when we are trying to infer some knowledge or information from the data. Suppose, let's say we make a hypothesis and test that, then we get back some inference from that, correct? And that is what we refer as inferential statistics. So if you talk about the hypothesis testing, so now the first thing that pops in the mind is, again, what exactly is our hypothesis is. So we can refer that in simple layman terms as assumption. So hypothesis testing is simply inclusive of the state of hypothesis as well. So where we are going to discuss on the stages involved stating the null and alternative hypothesis here. And then we are going to focus on formulating an analysis plan. So where it involves the construction of an analysis plan here. And then it analyzes the sample data, where in this stage, it simply involves the calculation and interpretation of the test statistics as described in the analysis plan. And then we have interpret results, where this stage involves the application of the decision rule described in the analysis plan here. So we can say, let's suppose if we have to test the hypothesis here. So we can say, let's say we have, again, the event is free of bias here. So what is the probability of John not cheating when the, okay, so the serial is being distributed here? So P John not picked for a day is going to be 3 out of 4. John not picked for 3 days, it is going to be 3 by 4, 3 by 4, 3 by 4. That's going to be 0.42. And B, and the probability of John not picked for 12 days, it is going to be 3 by 4 multiplied by 12. That is going to be 0.032, which is going to be greater than 0.05. So the null hypothesis is going to be the result is no different from assumption, and the alternative hypothesis is the results that disapproves the assumption here. So the probability of this event is greater than 0.05. There's a 5%, and that's how we can work with the testing here. So this was an overview of the mathematics that we are going to cover as a part of our discussion on machine learning concepts. Thank you.